All right, BSides CT 2020. I hope everyone's doing well. I hope during that break you registered for the raffle with Palo Alto Networks and CloudKnox. Good luck. I hope you guys win. Coming up next, we have Michael Raggo. He's going to give a talk on cloud breach incident response and forensics. Should be a good one. So let's bring Michael in now and let him start his talk. Hi, Michael.
Hey, how's it going today?
Great. I pass it off to you and have a great talk.
Awesome. Thanks so much. Let me share up my slides. All right. So just a quick thumbs up if everybody can see my slides here. I'll assume that's a yes, so I'll go ahead and get started. So hey everyone, this is Mike Raggo with CloudKnox. Today I'll be presenting Cloud Breach Incident Response and Forensics. This was a bit ad hoc. We were sponsoring the show, and Tom happened to post that there was availability for a slot that someone had canceled. So we jumped in to present this. So looking forward to being here. I am originally from Connecticut, although I live in Atlanta. I was born and raised in East Hartford. And then after college, I moved to Atlanta. Broadcasting here from sunny Atlanta. So we'll go ahead and jump right into it. I don't normally like to talk too much about myself, and I was kind of inspired by Matt's talk, the previous talk just before this, where he talked about aspects of breaking into the cybersecurity industry and aspects of that. I was fortunate enough to fall into cybersecurity by accident. So circa 1993, 1994, I was working at the NASDAQ stock market and as a Unix system administrator and Oracle DBA. And at the time, I was always one of those guys that really enjoyed tinkering around with things. And there was the guy, Dan Farmer, at the time, very well respected at the time in cybersecurity. And he released a vulnerability scanning tool long before there were commercial vulnerability scanning tools called Satan, of all things. And I downloaded the tool and decided I would run it on the NASDAQ network on the trading floor systems in the middle of the day. And proceeded to do so and accidentally took down the trading floor in the middle of the day. Fortunately, we had high availability. As you may know, the backup location for NASDAQ is actually there in Trumbull, Connecticut. And things failed over just fine, but I had a massive fail and was at risk of being fired. So I was called into the CISO's office at the time. He basically sat me down and I was super afraid. I mean, it was grounds for being fired. And he said, I'm here to offer you one of two things. You can either be fired or I'll offer you a promotion. So I took the promotion and asked questions later. And he basically said, listen, we don't have any security people here at NASDAQ. Again, this was 1994. We've got some compliance people. You clearly demonstrated you could take down the network, albeit, by accident. But now it's going to be your job to protect it. And so I took on the job, and that was basically how I broke into cybersecurity, and I've never looked back. So thanks for having me. We'll go ahead and jump right into the content then. If you ever have any interest around cybersecurity books, I've written a number of them, including mobile data loss, and then a book on data hiding, which is around covert communications. I've presented at a variety of shows, including DEF CON many, many times, both on the main stage and also DEF CON demo labs, the IoT Village, Sky Talks, Wall of Sheep, and a variety of other things. So if you enjoy, chit-chatting about cybersecurity, feel free to connect with me on LinkedIn. Always happy to chat more. So in terms of the content then, forensics and incident response and in the context of the cloud, one of the frequently asked questions anytime you first get into forensics and incident response, or if you're already in the field but taking on a new technology or a discipline is, what the heck am I looking for? So in the state of cloud security, or in the context of cloud security, there's a lot of interesting aspects that are both similar and different about the cloud. When you think about where we've come from, right? It's, back when I was working at NASDAQ, we were looking at, aspects of implementing firewalls and other layers of defense. And then around the year 2000, I was teaching ethical hacking classes, and people were starting to ask, what do I need beyond a firewall? I'm trying to protect my on-prem network. I'm trying to protect my website. And people were starting to look at IDS, malware protection systems, endpoint security, and other layers of defense. And if you fast forward to today, in the context of the cloud, we're finding more and more people are trying to shore up their security in the cloud. And we'll talk about aspects of the tactics, techniques, and procedures, or TTPs, related to many of the breaches that have occurred recently. Rami did a really, really good presentation earlier talking about many of the breaches. We'll continue to pull the onion back a little bit more, peel the onion back a little bit more in terms of revealing some of those high-level risks that led to a lot of those breaches, and really kind of dovetail onto what he presented. In addition, recently wrote an article for Forbes, and it was really breaking down the cyber kill chain, but in the context of the cloud. What's different about the cloud that I need to think about? And then we'll start to dive into AWS and Azure. We'll touch a little bit on GCP, but it's a lot of ground to cover in a 45-minute presentation. We could probably cover a whole week on this stuff. So hopefully you guys enjoy it. Let's jump into it. All right. So first of all, what am I looking for? One of the big aspects about security and kind of a tipping point that we're seeing today is moving beyond signature and signature-based detections. With, the inflection point of machine learning and AI in general, we're finding more and more there's a lot of good data that comes out of doing anomaly-based analysis. And therefore, leveraging various technologies as well as open source tools will allow you to identify things like a huge uptick in activity that is very abnormal for an identity or people accessing resources in the cloud. And whether it's a human or a non-human, like a service account, these are very important data points in the cloud that'll really help you find some cool and interesting stuff that we're going to show you. Additionally, there are a plethora of resources in the cloud, various services. If you look, for example, within AWS, not only do you have EC2 instances and S3 buckets, but you've got DynamoDB, Elasticsearch, a plethora of different services and resources out there. If you're talking about Azure, you've got blobs, containers, VMs, instances, but a whole variety of different services and resources that are available out there. Understanding the chemistry of a lot of those services and resources becomes increasingly important, as you might expect, when you're doing forensics and incident response in the cloud. Also is the access methods. Many of us may be very familiar with traditional approaches of RDP and Secure Shell and methods by which people can access things through username and password, but also keys and other mechanisms. There are some new approaches in the cloud. For example, within AWS, they have AWS access keys and a secret key associated with that. When people go to administer AWS, they may do it through the web console, or they may do it through the command line. So AWS provides a CLI and SDK you can download, and it's used more frequently by developers and administrators for administering AWS rather than using the web console. It's something that's unique to AWS, and also because of that, it becomes a big target for hackers, and we'll talk more about that too. We also want to talk about not only aspects of initially breaching the environment, but like we've looked at traditional cyber kill chains in the context of lateral movement, privilege escalation, and those other steps that ultimately lead to some type of denial of service, exfiltration of data, and more, understanding how those things are connected to one another and what's different about the cloud is something else we'll touch on too. Many times accounts are breached also because they're inactive and not being used. We do a lot of assessments for a lot of organizations. And one of the systemic things we find is a plethora of inactive identities that have been created in the cloud, but never ever used. They may be people that have left the company, people that simply aren't using the cloud access when they thought they might need it, or furthermore, a business partner you're no longer doing business with. So finding and identifying those is going to allow you to become more proactive too. And then those traditional things around source IP, geo, and then something called a security group, which is kind of a fancy name for a firewall policy in the cloud, or an ACL. It's more of a virtual firewall rule set for ingress and egress. And this becomes increasingly important too, and we'll talk more about that. And then also something called cross-account activities. All right, so why is this such a big problem? And even if we refer back to Rami's presentation, why are so many people getting breached? You saw in his presentation, he talked a lot about S3 buckets and also exposed services. The one systemic thing across all of those breaches is that over-permissioned access was a systemic and intrinsic problem related to every single one of those breaches he highlighted and breaches highlighted by the recent Cloud Security Alliance report. When you look at all the permissions in the cloud, for example, in Azure, you've got more than 8,000 default permissions. And in AWS, you've got more than 8,000 default permissions. For GCP, thousands of them, right? So if you've got a hybrid cloud in the environment, or you're doing incident response and forensics, it's important to understand that although there may be various types of indicators of compromise, maybe in AWS, you certainly want to ask the organization, do you guys have a hybrid cloud environment? Do you guys also have Azure and GCP? More than 50% of the companies out there have a hybrid environment. And it's likely if one environment was breached, it may have led to a breach somewhere else across the cloud infrastructure. What's really interesting about this is, do you as an organization or the organization you're working with understand those 8,000 permissions? It's really difficult to understand what those all are. And of those, which ones are high risk? More than 50% of them can allow you to do a mass delete or create within the environment. Both can be equally dangerous. And lastly, the one systemic thing we know across all organizations we work with is that as permissions are assigned to developers, DBAs, the IAM team, security groups, and other people, is that on average, less than 1% of the permissions assigned are actually used. So it comes as no surprise that one of the main reasons people are getting breached is that once an identity is breached, it has far too much access based on what it actually uses. But don't take my word for it. The Cloud Security Alliance released a report this year, an infographic, highlighting 11 different cloud security breaches. Rami touched on some of them earlier. There's some other very interesting ones in here also. Two of these were ones we were kind of highlighting before this report came out. So we found it kind of interesting that two of the 11 they highlight are ones that we kind of break down in terms of the TTPs. Awesome report from the Cloud Security Alliance. Definitely get out there and check this out. You see just in this one example, they break down all the TTPs for you, and it allows you to understand the steps that led to the breach in a kill chain scenario. One other really powerful thing about the cloud is, developers may have access to the whole stack. This is very different than 20, 25 years ago. For example, maybe when I was working at NASDAQ, as an administrator, I would give out, access kind of a little bit more on a least privileges basis, definitely separation of duties where, we would say, well, listen, you're a developer, you get this level of access. You're a DBA, you get access to the databases and the ability to do snapshots and backups. But today's world of the cloud, developers more and more have access to the whole stack. Whereas we would have a different team that would build out the servers, a different team that would build out the network and the firewalling rules. Because that's all virtual, that entire stack can be spun up in less than 15 minutes. And it gives developers a really powerful level of access. And from that stems a lot of mistakes. In addition, in the event that you're breached, one command can certainly destroy some, if not all, of your cloud infrastructure. So the stakes are very, very high as well. So I put together this diagram to really look at this in the context of the kill chain analysis. Back when I was teaching ethical hacking classes around the year 2000, we would talk about this thing called a kill chain. And it was, a lot of people were starting to talk about it. It was sort of a new concept. Now that it's really instilled in the security community, I took a look at this and many of the things that we do in terms of research and what we present at conferences and said, we really need to map this out from a cloud infrastructure perspective. Like if I'm running AWS, like what's different about the kill chain? If I'm running Azure or GCP, what's different about the kill chain? If I'm going to be administering this, if I'm going to be fortifying the security, if I'm going to be doing incident response and forensics, I need to understand what's different about the cloud and how this actually maps to a cyber kill chain. Where we find a lot of organizations that we work with today are kind of around the recon phase, whereby they're starting to shore up their cloud infrastructure and misconfigurations, or they have already. So they've got that initial firewall in place, if you will, where they've looked at and try to avoid exposures of S3 buckets, public resources like an RDS database, or an AWS, or a variety of different things like that. Is anything exposed to the outside world? But what we're finding based on many of the breaches is that the breach doesn't stop there. Well, although that type of thing may lead to an exposure of data, all of the recent breaches were far more sophisticated than that. And as a result, we're seeing the second generation of TTPs. One of those is exploiting these IAM permissions. We'll talk a little bit more about the how in just a moment. But when you've got identities out there that are using less than 1% of their permissions, there's a lot of avoidable risk sitting out there. And as a result, this is being exploited by the attackers to then not only infiltrate the initial environment, but allow them to do things such as privilege escalation and lateral movement. For example, with AWS, you have the ability for cross-account access, kind of role chaining, if you will. What that means in the context of AWS, for example, is, hey, I may have different accounts or subscriptions. How I provide access is through a role called the SDS assume role. And based on that policy, designate what permissions people have where they may live in one account, but need to access another or another subscription. The SDS assume role controls what kind of access they have essentially in that second, third, fourth, fifth, and beyond subscriptions across your cloud infrastructure. Attackers look for that too. And if the identity they've exploited has far too broad permissions, that's going to allow them to maybe change policies for cross-account access and do privilege escalation and lateral movement. And remember, when it comes to exfiltration in the cloud, even if you have read-only access, that allows you to not only read the data, but download it. It may seem obvious to many of us in the cybersecurity space, but when you talk to a customer, most customers have an oh wow moment when they hear that, right? All right, so let's break down a few attacks for you. This was a very popular financial services institution breach. Rami actually covered this to an extent in his presentation. We'll kind of elaborate on it a little bit more from an IR and forensics perspective. In this particular financial services institution breach, initially the web application firewall was breached. But what was interesting about that once that occurred was that the attacker gained access to a particular identity. And from that, was able to leverage the permissions assigned to that identity to do some pretty damaging things. First of all, that identity had a sole purpose. Its purpose was tied to the application it was serving out, but it had access to 700 other S3 buckets it had never used. And so as the attacker leveraged some scripting and was able to quickly map the environment, as we just outlined in the cyber kill chain scenario, uncovered that one of these S3 buckets sitting out there had a lot of sensitive data in it. And even with read-only access, was able to view it and make a copy of it and exfiltrate that data. So from an incident response and forensics perspective, there were some interesting characteristics related to ideally what you would find in the logs in this type of incident. One is a huge uptick in activity stemming from a whole lot of new permissions the user is now using, which had never been observed before. Huge anomaly. Second, quickly accessing a huge portion of resources that the identity had access to, but had never used up until this point. And then thirdly, the time of day. This stems also from a lot of default policies. Many of these are in a JSON format. That could be said for Azure as well as for AWS. In this example, we've got a default policy within AWS. And these characteristics of the default policy have a lot of asterisks. For example, resource star. which effectively grants administrator access. Understanding these policies across the environment becomes super complex when your environment really grows like a carbon life form. We mentioned many times around over-permissioned access. This is just one example where we've got an identity, a user, who's got a whole ton of permissions and has used very little of those. And furthermore, identifying of those, which ones are high risk. And we're going to give you some really cool examples of that in just a moment. Another incident involved a very popular security vendor. For us folks in the cybersecurity space, it's a household name. This particular security vendor had a couple failures, or boo-boos, if you will. And that is, first of all, they had poor development security, meaning that what we mentioned earlier around AWS keys is that a developer can access the AWS environment through the web portal. Maybe you require multi-factor authentication, or altogether, instead you can use AWS access keys. That creates a key and then a relevant secret key. If you've never used this, you can kind of think of this like Secure Shell. But what's interesting about that is there's no multi-factor authentication. So if you have a developer that embeds those keys in code and posts it to GitHub, anybody out there who tries to crawl through your code and uncovers those keys can gain the keys to the kingdom. And that's exactly what happened here. The developer posted the code to GitHub, and some attacker found that these access keys were sitting out there. The other failure was that the developer, because he had access to the whole stack, far too many permissions for a developer, had created a backup or snapshot of RDS, the database service. And because that backup had been misconfigured, it was sitting out there, and with the access keys, the attacker was able to access the backup snapshot. What's interesting about this is not only did it contain the user accounts and password hashes, which obviously are bad, but being a longtime employee of VeriSign, I would argue the even bigger breach was the certificates and all of their private keys. For every 13,000 customers around the world, every single web application firewall they have. So this vendor had to go out and, following this breach, touch every single one of those firewalls, web application firewalls, and swap out their certificates and private keys. AWS also recommends, as part of their best practices, that you rotate AWS access keys every 90 days. Well, although that's not a silver bullet, it's a defense in depth strategy, right? So if you're rotating these keys on a regular basis, maybe ideally by the time the attacker finds them in GitHub or somewhere else, they've already expired. Okay? Again, not a silver bullet, right? But just kind of a best practice. And the other thing that they recommend is any keys that aren't being used, just go ahead and decommission them. By default, many times, when people create identities within AWS, they automatically create the access keys. So they sit out there forever, and they're just sitting there as low-hanging fruit potentially. So again, not only rotating them for the active keys, but anybody who's not using them, just go ahead and decommission them. And you can gain insights into when they're being used, if they're actively being used or not. Because there are so many permissions in the cloud, I decided to kind of break some of these out to really bring these to light. Of the 8,000 plus permissions available in AWS, more than 2,000 of them are very, very dangerous. But more times than not, when we do assessments for customers, we find that each and every identity in their entire AWS environment has all 8,000 permissions. So what does that mean in the context of their security hygiene? And what are attackers using to gain access to the environment? Well, one of those is the EC2 authorized security group ingress. And as you might expect, this is related to your EC2 instances, or essentially your VMs. With this default permission, if it's assigned to any user, it gives them the ability to change the firewall policy protecting your EC2 instances for all ingress. So do you want any user to have the ability to enable to the entire world 0000 and open up Secure Shell, RDP, and a bunch of other services? Obviously not, right? But we find this in almost every organization we work with. Another one is related to insider threat. More and more you hear people talking about insider threat as well. And especially in the cloud, there's no better person to exploit the environment, right, than somebody who already has access to it. So one of the default permissions also given to many users is the IAM create user. This effectively allows any user with this permission to create a dummy account for themselves. So now they can do activities, nefarious activities, not as themselves, but as a dummy account user, and basically hide their tracks. Obviously very dangerous, something you probably don't want most users to have access to. But again, we find this in almost every organization we work with. If we start to map this out to lateral movement as well, you have what I mentioned earlier around cross-account access, being able to jump from subscription to subscription or account to account, as they call it in AWS. With this update assume role policy, IAM, allows you to effectively grant permissions to assume a role, effectively changing the STS assume role capabilities to give you broader access. So if you breach an identity and you find it has this permission, you can go ahead and change the policies as well. And that's going to allow you to access other subscriptions or accounts when the identity wasn't originally designed to do that. And then in terms of privilege escalation, the IAM put user policy, another default permission, allows you to basically update or create an inline policy, giving you permissions, maybe full admin to an S3 bucket or a variety of S3 buckets. So again, quite dangerous and can allow all different types of privilege escalation. So if we bring this back and then we start to dive into the forensic side of this, when we look at this from the kill chain analysis and in terms of what we should look for, we're starting to peel this onion back more and more. In terms of the perimeter, people think about public S3 buckets. They think about exposures of the AWS keys. They think about cloud misconfigurations. But now these tactics, techniques, and procedures are definitely maturing, where we can now take a closer look at how they exploit over permissioned identities, those IAM permissions, identity and access permissions. The fact that if you're using AWS access keys, there is no MFA in place. And dormant accounts, inactive identities, inactive roles, inactive resources become low-hanging fruit targets also for an attacker. So as we continue down this path in this presentation, we'll talk more and more about role chaining over permissioned access and start to take a look at some logs and what a lot of this stuff looks like. And we're going to start to talk also about Azure too. So if you're more on the Azure side, we're going to give you a variety of things to look at as well. It's really hard to do this manually. So if you think when you jump into this, hey, I'm just going to look at the logs and see if I can figure this out, whether you're looking at Cloudtrail, or you're looking at Microsoft Graph, whether you're looking at Azure Active Directory Graph, there are a plethora of logs. And it really comes down to either using open source tools or commercial tools to aggregate a lot of that data and really find those needles in the haystack, but also understand those what we call toxic combinations, where you can cross-correlate those specific findings in the logs. Otherwise, you're finding lots of needles in the haystack, but you don't necessarily understand the relationship between them. It's really, really difficult to do. And then in terms of authorization models, what we're talking about here is all of those permissions. Of those 8,000 permissions, if I'm looking in the logs, do I really know what all those permissions are? It can be really, really difficult. We're providing a few unique scenarios today in this presentation, but there is just a plethora of different types of permissions and resources sitting out there. So it can be quite daunting. So where do I go and look for sources of forensic data? A moment ago, I mentioned for AWS that might be Cloudtrail. You can look at Access Analyzer and Access Advisor. There's now also CloudWatch and even Control Tower too within AWS. For Azure, you've got Microsoft Graph and Azure Active Directory Graph. And then also Security Center is actually pretty good, and we're going to highlight that too. One of the interesting things I find about Azure, is, we're mostly talking about cloud infrastructure here. What that means is compute, where areas in which people are doing development and hosting applications, not so much on the Office 365 side. But that said, I will highlight a few things for you on the Office 365 side, or Microsoft 365 as they're calling it now. What's interesting about that is a lot of people don't realize it, and when we work with organizations, we kind of make them aware of this, is that if you're running Office 365, whether you realize it or not, you have Azure. Azure runs behind the scenes. You probably have a separate login for Azure you didn't even know existed. And later, when we talk about how to improve the security hygiene within Azure, many times the default logs are only kept for 7 days. If you've got an E3 or an E5 level, then it might be as long as 30 days. But is that enough, right? If you take a look at any of the metrics over the last number of years, on average, it's 6 months before somebody actually realizes they had a breach. So if you only have 30 days of logs and you have to go back 6 months, they're gone. So within Azure, the reason Azure can exist behind the scenes is through a simple PowerShell script, you can run backups of those logs and allow basically to store those logs forever should you ever need them. And then in GCP, you've got Google Cloud Logs, and then there's a plethora of commercial products out there too. If you're looking in AWS, these logs are stored within Cloudtrail. And if you look at Cloudtrail, whether it's online or you export it to a CSV or a JSON, or you're consuming it into Splunk or something else, there are a plethora of logs because they not only contain information about who's accessing what, where, and when. There's a lot of information regarding changes in configurations and just really all the overall activity going on, even across development and everything else. If you export this and you look at the actual JSON, there's some interesting characteristics here. One is to distinguish what type of authentication method was used. Were they logging into the web portal, or did they use AWS access keys? Here in this case, you can see the access key ID. That means they're using access keys, not a username and password credentials. In addition, remember that AWS access keys, there's no MFA related to that, right? So protecting those becomes increasingly important. And then in addition, what was actually performed? The event name says list buckets. So they're listing the storage or S3 buckets, if you will. And then what we traditionally see, from a forensics perspective is, where did this come from, right? What's the source IP address? And do I have any information about who they are or where, what type of device they're using? So we'll highlight aspects of the browser, which all of this combined allows you to create a profile or fingerprint for the person who basically ideally generated this log as a byproduct of the activity they were doing. Now, this log wasn't a legitimate log. This was just normal activity going on. But distinguishing this from something nefarious becomes, comparing that to legitimate logs and understanding those differences. In this case here, we see the same access key being used and the same activity being done, which is list buckets. But it's stemming from a different source IP address and characteristics of a different browser. Again, just a very fundamental starting point in terms of doing forensics here, but very important, very powerful information. It goes beyond just understanding some of these simple characteristics, but being able to identify those anomalies. One of the interesting things about AWS is you have the ability for a CloudFormation template. This allows you to build a template that allows you to quickly spin up infrastructure. This is how infrastructure people and even sometimes developers are quickly spinning up infrastructure rather than going in and setting all the switches and buttons. If they're frequently creating infrastructure that's very similar or identical to one another, the CloudFormation template or YAML file allows them to quickly run that, spin up the infrastructure, and get up and running even quicker. More broadly, there's an open source version called Terraform, which is frequently used across AWS, Azure, and GCP for that matter. In this case here, though, AWS and the Cloud Security Alliance provided documentation around creating a clean room. So when you're doing traditional forensics, you have this concept of a clean room, right? If you're doing mobile forensics or forensics on a computer or something else, you have a clean room in which you do that analysis. You may make a backup of that device so that you can then analyze the data, not resident on the device, but keep that virgin and available for should you have to go to court and present on those results. But rather go ahead and make a copy of it and do your forensics on the copy instead. That's what we're talking about here, but in the context of the cloud, called a clean room. So the Cloud Security Alliance released this really cool blog that talks about how to set this up. And AWS has information on their site too. So you can either have this running or quickly spin this up should you ever need it, should you encounter a cloud breach. This allows you to effectively leverage what you may be doing already or should consider doing in terms of doing snapshots of volumes, recording metadata, and having this information available, but additionally being able to quickly spin up this clean room and then be able to perform quick on-the-spot forensics, again, without actually touching the originating data, but an actual backup of it in a clean room scenario. So pretty cool. It does have also some workflows too, and things related to Slack, which is quite interesting. If you're really interested in this stuff, you can not only check out this link, but you can follow the AWS Slack channel too, and they have a categorization for forensics, which is actually really cool. All right, so I know a lot of people out there are Azure, and a few people hit me up already like, hey, what about Azure? What about Azure? So let's talk about Azure. If you're familiar with doing Microsoft, administration, you may be familiar with using things like PowerShell and automating through scripts a lot of your daily tasks. This now exists within Azure, also in the form of Bash or PowerShell, basically a command line interface directly in the browser. Why is this interesting? Well, for so many years, people would open up RDP and try to remote in and do a lot of this activity. Now you can do it directly through the browser. So this creates a different way by which you're accessing the environment and gaining access to PowerShell without having to mess too much with opening up too many ports and too many services to too many IPs, which is where a lot of misconfigurations occur. So you can find this at the top right, click on the command line. It'll ask you if you want Bash or PowerShell. And from that, it'll open up the relevant screen at the very bottom of the browser. And you can expand this so that you can go in here and do a variety of activities. Now, what's interesting about this is this unto itself can open up specific risks. The reason I mention this is that we've seen this with some of the Azure breaches. So when you use Azure Cloud Shell, it's great, right? You can do all the typical type of PowerShell things that you're familiar with doing, but now on the cloud and in the context of Azure related to your subscription. But unfortunately, some of the commandlets and some of the error logs end up within specific folders for that account, within the .azure folder. And as a result of that, within those logs and clear text can be things like credentials and other things that you may be running. It's almost like a history file, if you will. NetSpy did a really good blog on this to bring out a lot of these examples. So if you're an attacker and you're able to breach Joe user in an Azure environment in the cloud, maybe you can see what exists at a PowerShell level within Joe user's account. Meaning you can navigate to these different directories, to .azure folder and others, to see if any of these history files actually exist. If this person does administrative activities, you may find the credentials that they use to then log into other subscriptions or do other activities, as you see here. And in clear text, this will store the username and password in clear text. This effectively allows you then to do that privilege escalation and escalate your privileges. And it's one of the most frequently targeted things within Azure. Azure actually does a particularly good job, in my humble opinion, in terms of dashboarding. I know for many years, people like to pick on Microsoft, but in terms of Security Center, it's actually some pretty good and quick actionable type of data you can uncover when you go into Security Center. Again, the level of access you have here will definitely depend upon your level of subscription, whether it's basic, E3, or E5. Some of what you see here on the screen is at the highest level, E5, the most broadest subscription that you can subscribe to. At the bottom, you get all the threat protection information, and on the bottom right, all the relevant alerts. These are categorized for you, and they actually provide some really good information. These alerts you can drill into individually to gain deeper insights into each and every particular alert and when they occurred. Here we can see brute force attacks occurring via Secure Shell. They are failing, but we can see that brute force activity. Furthermore, you can drill into these individually and then see what accounts they may be trying. Here we can see a lot of default logins that they're trying to use as they brute force. We can also see what IP address they're coming from, what subscriptions and even resources they may be targeting, both on the left and on the right here in the screen. So again, quick actionable data that's been bubbled up in terms of the threat protection related to the Azure environment. A lot of customers use this to kind of improve their security hygiene over time. We saw failed Secure Shell logins. Should that be further restricted, and how can they do that within Azure? So we provide the prescriptive advice about how to do that. So through this, you can learn how to shore up your security, hopefully more proactively prior to a breach. This talk isn't really about Office 365, but I've got some experience doing incident response, with things like Exchange Online, and it's always a frequently asked question that over time I finally just decided to add a slide here and highlight that for a moment. One big example, probably one of the most prominent things I see and have seen over the years in doing, like cloud forensics, if you will, and incident response, is around Exchange Online. When Exchange Online email users are created, one of the unknown things to most administrators is that PowerShell is enabled for every single user you create, meaning that it becomes low-hanging fruit for an attacker. So if you pause and think to yourself for a moment, gee, I've got all of these people that are using Exchange Online. They're probably across, HR, marketing, accounting, different business functions across, how many of them are actually going to use PowerShell? If I was placing odds in Vegas, I'd say probably less than 1%, right? And in the event that their identity is breached within Exchange, what can be done? Well, first of all, PowerShell is available, but again, only for their account. But even with that, you'll find attackers have automated scripts that'll pull down distribution lists, a list of all their contacts, the ability to send emails from that account to phish or target other accounts within the company, and additionally, immediately remove those emails from the sent folder many times before some of your security tools identify the activity has happened. So there's a lot of interesting characteristics here. Certainly you want to look for activity in the logs that would indicate when something has been marked unread. So somebody read an email, they then marked it unread. It'll happen from time to time, but what we find in most cases is it's not very common. So if you've got other indicators of compromise, and with that particular account, you see unread or deleted emails occurring from the sent folder, this builds out your case much stronger in terms of those indicators of compromise. And then look for those suspicious email forwarding addresses too. The bottom line here is, if you don't need PowerShell for most of those users, just disable it. They're probably not using it anyways. Microsoft has some default scripts sitting out there for PowerShell that you can use to broadly turn this off, and you can create a separate file of just the accounts that you want to continue to have it, and it'll do a quick sweep and disable it for those 99% of the users that'll never use PowerShell. Yeah, Andre is posting some really cool stuff here too. Thanks, Andre. So rounding this out and additional advice, Scott Piper, one of the leading, AWS thought leaders, security thought leaders in the industry, posts every day to Twitter, has an awesome blog. He also runs the Forward CloudSec conference, which is like a BSides show just before the annual AWS reInvent conference. He's got some incredible blogs you can go out and check out, all focused around AWS. Rhino Security does some incredible reverse engineering research, and many of those breaches that we've spoken about, not only myself, but what the Cloud Security Alliance covered and what Rami covered in his presentation earlier, are broken down by Rhino Security. So you can understand many of the commands and things that were run leading up and post-mortem following those breaches. Earlier, we highlighted the forensic readiness tool for AWS, or not tool, but steps and process. This is really good to have in your incident response playbooks. So if you have playbooks within your organization, it's awesome to have this, because in the event you ever have a breach within AWS, now you've got, a response, right? How would we set a clean room? Let's set up that CloudFormation template in advance and have that ready to go. And then for Azure, they do an ongoing video series called Azure Hacker Hunting, which is also particularly good. Highly recommend out there, if you ever want to watch those. To the question from Jenner, yeah, absolutely. I'll be sharing the slides to all of you so you guys can have the links and everything we've presented today. Happy to do that. All right, so just wrapping this up then. Hygiene. So again, we said a lot of this stems from permissions and having those high-risk permissions assigned to a lot of users, developers, others that aren't even using those permissions. In the event that their identity is breached, do you really want all those permissions tied to that identity, thus allowing that to potentially be exploited and used for, lateral movement, privilege escalation, or exfiltration? Obviously not, right? So there are ways in which you can try to right-size that. I mean, we do that here at CloudKnox as a product, but in doing assessments with customers, giving them the prescriptive advice that, listen, do all these users really need IAM create user, the ability to change security groups for ingress to all your services and resources, or to modify the STS assume role, giving them access, broader access to a variety of other AWS subscriptions or accounts. Also, if you've got identities that aren't being used, consider disabling them or removing them altogether. Every organization we work with has old stale accounts sitting out there that aren't being used, and they're just low-hanging fruit. Also, is that around anomaly and outlier detection. There's a lot of capabilities today leveraging machine learning. We do this as well. But with machine learning, you can baseline on the activity for each and every identity to then understand what's normal. And the machine learning then will allow you to identify those big anomalies in the event that you have an emerging breach or an attack going on. So I'll leave you with one lasting thought, and then if we have time for Q&A, more than happy to do that. Stephen Schmidt, CISO, AWS, sent a letter to a senator following one of the breaches we actually had discussed earlier and said, listen, even if you have a customer that misconfigures a resource, if the customer properly implements a least privilege policy, there's relatively little an actor has access to once they are authenticated, thus significantly diminishing the customer's risk. What they're basically saying here is, if you can remove a lot of those unnecessary permissions, you're going to minimize your blast radius in the event that you have a breach. And so it becomes a critical part of, and has found to be a huge indicator of compromise in all of the breaches that have been highlighted. And so it really becomes the pivotal point at which you really want to start to trim back a lot of those permissions. So happy to send out a copy of the slides. I'll try to post them in Discord, or feel free to email me as well. You can follow us on Twitter at CloudKnox. You can follow myself as well. CloudKnox website is www.cloudknox.io. And thanks so much for your time. I really appreciate it. Really Happy to present to BSides Connecticut. I'm originally from Connecticut, as I mentioned, born and raised in East Hartford, although I live in Atlanta now. So really great to present to all the local folks there in Connecticut. And thanks so much for your time. I'll hang out here if you guys have any questions, and I'll also take a look in the chat window if anybody posts anything. Thanks so much.